everyone, today we're going to look at how we simplify cube roots. What's going to be nice about this is it's really not a whole lot different than what we did with simplifying square roots. But first let's just talk about the parts of a cube root. So just like square roots, we have this symbol here that we call the radical symbol. The number underneath is called the radicand, and then this time we have a number sitting here kind of inside the little crook of that radical symbol, and that's our index. With a square root, there's a 2 there, we just don't see it. Anything above that, though, there will always be a number there. So what we're going to do first is we're going to take a look at what these would look like if we did them in the calculator. So I'm going to go ahead and split my screen so we can take a look at those. So to find our cube root symbol, because we have the regular square root symbol here, but to get a cube root, we have to go over the functions. And then we go over to the miscellaneous. So make sure you tab all the way over to miscellaneous. And then we have this radical symbol in the corner. So I'm going to click that, and now we're going to notice the little cursor is up here above the hook. So I'm going to type 3 because it's a cube root. Now I can go inside and type in my 27, and we get that our answer is 3. So I'm going to come over here and write down that the answer is 3. Alright, so now let's take a look at the cube root of 1000. So I can do the same thing. I'm going to come over here. I'm going to go to functions. Again, pick this and type a 3 inside the hook. And then I can type in 1000. So now we see that the cube root is 10. So I can come back over here and put 10. Alright, so now let's take a look at the cube root of 343. So I'm going to come here, 3 there, and then 343, and we get 7. Now, number 4 and 5, we're going to know something a little bit different about those two. They both have negatives underneath. We didn't really touch on this at all with the square roots, and we'll get to it more in Algebra 2. But we can't actually find the negative like the square root of a negative number. So, for example, if I want to do the square root of negative 81, it tells me it's undefined. Right? Because remember, a square root means you have to have 2 numbers that multiply to make the inside number. So there's no, if I multiply 2 negative numbers together, it's always going to be a positive. And multiply 2 positive numbers together, it's always going to be a positive. So it's impossible to find a square root of a negative number. Alright, but cube roots are a little different. So let's see what we can do for a cube root. So I'm going to come here, type my 3 in, and this time I'm going to do negative 216. And what happens? Well, now we find that the cube root is also negative. So if the inside number is negative, my cube root is also negative. Come over here. And 6. And then we're going to do the same thing for that last example. So once again, since the inside number is negative, we're going to notice that our cube root is also negative. And then we'll put negative 12. Why does that happen? Why is it that we can have negative cube roots, but we can't have negative square roots? Well, like I said, with square roots, it's impossible to multiply two of the same number together and get a negative number. If they have the same sign, they're always going to come out positive. But with cube roots, we have to be able to multiply 3 of the same number together. So if I did 2 negatives, they're going to make a positive. But as soon as I multiply the third negative, it makes my answer negative again. So that's something we have to be aware of, that when we're dealing with negative numbers, its cube root will always be negative. Alright, so let's come down here. And I'm not going to spend really much time on this, but this is just the perfect cubes. So if simplifying square roots was easy for you using just the perfect square method, then you could do the same thing with cubes. So here's your list of perfect cubes, and you can use that to help you. when we come down to a little to our next page, I'm going to utilize the birthday cake method, but remember we also went over the factor tree method last class, which you can also use here. So when we're simplifying cube roots, nothing much has really changed. We can still use any of those three methods that you've learned. Except now, instead of doubles, we're looking for triples. So that's going to be our key here. Alright, so let's take a look at this first one. So I'm going to start with that 875. And actually, before we do that, let's go back and review what those prime numbers are. What were all those prime numbers? Because those are all pretty important for us. So prime numbers, and we want those. So we have 2, 3, 5, 7, 11, 13, 17, 19, and we'll keep going. But those are the ones that we see most often. Alright, so let's start with that 875. Alright, so 875. I'm going to start my birthday cake. I'm going to give myself some rooms. I'm going to come down here, 875. It's odd, so I can't divide it by 2. There is a quick little shortcut for 3 if you wanted to see. So I could add up the digits. 8 plus 7 plus 5 gives me 20. Since it adds up to a number that's not divisible by 3, then these 3 can't go in place. But I can still divide this by 5. So I'm going to divide this by 5. So 875 divided by 5 gives me 175. Right, I can check to see if this is divisible by 3, so I can add up all my numbers again, and I would end up with 13. So not divisible by 3, but it does end in a 5, so it's divisible by 5 again. And that gives me 35. 35 I know is also divisible by 5, and I can do it 7 times. 7 is divisible by 7, and that gives me 1. Alright, so remember when we hit 1, that's our birthday candle. All these numbers on the side have to be our prime numbers. Alright, so I can simplify this, or I can expand it out. So I've got 5 times 5 times 5 times 7. Alright, so now, this time we're looking for triples, but we're going to follow that same general plan that we did with square roots. So I'm going to look for triples. So in this case, I have 3 5s. I'm going to pull out 1 5 to represent that triple. And then my single, in this case, the 7, is going to stay home. And I have to remember to put that little 3 in the hook. I forgot to do that here. But because we're dealing with cube roots, since we have 3 here as our index, it has to be here as well in our answer. And then we're done. Right, now let's take a look at number 2. So this time we have a negative. When we go to do our birthday cake, we're going to actually ignore that negative for now. I'm just going to deal with the 576. Alright, so it ends in an even number, so it's divisible by 2. So I'm going to do 576 divided by 2, and I get 280. So again, even, divide by 2, and I get 144. Still even, so I can divide by 2 again, and I get 72. Still even, and I get 36. No, lots of 2's here. Still even, and that gives me 18. This is a really big birthday cake, so sometimes we have to keep going. Alright, we finally got a number not divisible by 2, so I can divide that by 3. And then there's my birthday cake. Alright, so what have we got here? I'm going to kind of do this. I'm going to look at, I don't want to have to rewrite all of it. So what I can do is instead of putting it back under that radical again, I can just look for my triples from the birthday cake. So there's 1 triple, and there's 2 triples. So that means I have to pull out 2 2's. Right? I have to pull out 2 2's. I'm going to pull out 2 to the second power. That 2 right there tells me how many triples I'm pulling out. Right? And then underneath, I've got those 2 3s left over. Right, well, now I can simplify. 2 squared is 4, and then 3 times 3, oop, I forgot my cube. That goes, my 3 that goes inside the hook. I always forget that, so please don't be like me. All right, and then we're done. Oh, but what did I forget? Remember we said if this number is negative, then this number that we pull out has to be negative. Right? That's a must. If this number here is negative, then the number we pull out has to be negative as well. All right, so now let's take a look at the next one. All right, so now we have 4. So now you have to be careful because now we're doing 4 times the cube root of 500. So we do problems like this with square roots. So let's start with our birthday cake. So I'm going to divide by 2, and I'm going to get 250. I'm going to divide by 2 again, and I'm going to get 125. Now I can divide that by 5, and I get 25. And I can divide 25 again by 5. Get 5. And then I can divide that by 5. And then there's my birthday. Alright, so remember, we have that 4 on the outside. So I have to do 4 times. Alright, so now I'm looking for my triples, and I happen to have 1 set of 5s. So I'll pull out 1 5 to represent that triple there. And then underneath, I'm not going to forget my 3 there this time, I got 2 2s. So we can only pull them out for cube roots if I have 3 of them. Doesn't matter if there's 2 2s, I'm not looking for perfect squares, I'm looking for perfect cubes. 4 times 5 gives me 20. And don't forget your little 3 in the hook. 2 times 2 is 4. And we're done. Alright, let's take a look at this one. So again, we've got to watch out for that negative at the 96. So I'm going to start with my birthday cake. So 96, I'm going to ignore the negative for now. I just have to remember I should go back and put that with my answer. Alright, so it's even, so I can divide by 2. And that gives me 48. Which I can also divide by 2, which gives me 24. And 2 again. And I can keep going with those 2's until I hit that one. So now I can divide by 3, and I get 1. Alright, so again, I'm going to look for any triples. So I've got a whole bunch of 2's, but I'm just looking for groups of 3. Right, that's the only group of 3 I have with the 2's. I only have 2 more 2's left over, and then I've got a 3 left over. Alright, so here's what we've got. So remember, we've got this negative 8 sitting on the outside. It's fine. Alright, I've got one group of 2. But remember, don't forget this guy's negative. So that means I've got to make that 2 that I'm pulling out negative. Okay, so if this is negative, the number I pull out has to be negative. Alright, back inside. Don't forget to put your little 3 inside the hook. I've got a 2, a 2, and a 3. 2 times 2 times 3. Alright, now I can go ahead and simplify. Now, we've got negative 8 times negative 2 is, oops, not negative, negative on the ring, is positive 16. And don't forget your 3 in the hook. And then I've got 2 times 2 times 3, which will give me 12. Done. Alright, let's throw in some variables. Now, so variables, it's going to be the same type of situation that we had with square roots. Except, again, we are just looking for cubes. Right, so we're going to just be looking for triples. And so, I'm going to break it down like I did. There is a shortcut way that you can do this. You may need to do a little more thinking though. It's not quite as straightforward as the shortcut was with the perfect squares, or with squares, where every time if it was odd, there was 1 left over. It's not quite as easy here. So sometimes it is easier just to group them, expand them out. So since I'm looking for triples, I'm going to put them kind of in groups of 3. Okay, times A times A, and then I've got 2 left over. All right, so looking for those triples, I've got a triple of x's and a triple of a's. So I can pull out one x to represent that group of x's, and then one a to pull to represent the group of a's. Left over underneath, I've got one x, two a's. So I write that as a squared. Done. Now what happens if we have a number underneath? Well, then we have to simplify that number first. So I'm going to birthday cake that 32. I can go in 16 times. There we go. So I'm going to look for my triples that way. So I've got one set of triples. All right, now I'm going to break down my variables. So I've got 7 w's. So I'm going to put them in threes then, just to make my life a little bit easier. Then, and then I've got 2 x's. All right, so now I can go ahead and do what I need to do. So I got one group of 2's. So I'm going to pull out 1, 2 to represent that group. I've got 2 groups of w's. So I'm going to put w squared, the 2 represents the 2 groups. And then that's it. I don't have anything else. Oh, I forgot to put my 3 in the hook over here. Don't forget. Don't be like Miss Broadhead. Alright, so now, what do I have left over inside? Well, I've got these 2's here. So 2 times 2 is going back in, so that's 4. And then I've got a single w. And then I've got 2 x's. Done. Alright, and then let's do this last one. Alright, so this one's tricky. We've got a few things going on. We've got this 6 going on outside, and we've got this negative on the inside. So we've got to pay attention to both of those. Alright, so first I'm going to birthday cake 81. Oh, and you know what? I did it again. I forgot my little 3 inside there. Don't be like Miss Broadhead. I'm so bad at that. Alright, so birthday cake 81. Alright, so I know 3 can go into 81. So if I do that, I get 27. I know 3 can go into 27 9 times. I know 3 can go into 9 3 times. And then 3 can go into 3 1 time. Alright, now I'm going to go ahead and break down my variables. So I've got 3 w's. 1, 2, 3. I've got 5 x's. 1, 2, 3, 4, 5. And then 8 z's. 2, 3, 4, 5, 6, 7, 8. Alright, and then I just kind of already grouping them into 3's just to make my life a little bit easier. Alright, so now I'm going to look for all my triples. Don't forget that we've got this 6 that I need to bring down. Times. Alright, I have 1 group of 3's. Alright, but don't forget that negative up here, which means that that 3 that I pull out has to be negative. Alright, now, what is left over? Oh wait, I forgot. My variables. So now, let's take a look at those variables. What do we have? Well, I've got 1 group of w's, 1 group of x's, and 2 groups of z's. So we've got w, x, z squared. These are 2 groups. And now, left over inside, don't forget your 3 inside the hook. We've got 1, 3, 2 x's, and 2 z's. Now to simplify finally, the 6 times negative 3 gives me negative 18. And then I'm just going to bring everything else there. And don't forget the 3 inside the hook. And then we are done. Alright, that is it for simplifying cube roots. Come into class next time, we'll kind of go over this a little bit and that will be it. All right, if you have any questions, please make sure you ask during class or come see me during office hours next week. All right, we'll see you guys in class. Bye.